Welcome all. Today's presentation would be microservices, performance testers dream or nightmare. You all have been hearing a lot about microservices lately in the technology forums. We all are moving away from the monolithic applications towards microservices. We hear about their advantages, their benefits, but as a performance tester, from a performance testing perspective, is it a boon or a bane for us? We'll talk about more now in the session. A little bit about me, as Rukaya mentioned, that I have been working within PE space for the last 15 years. I have primarily worked in retail investment and aviation sectors across the globe. I have worked majorly in Center of Excellence of HCL America, and now I'm working with Emirates from last 8 years, and I'm leading the Skywards program here. The agenda for today. So we'll just have a brief introduction about microservices. What are those? How different they are from monolithic architecture? What is the need of performance testing for microservices? Because we all hear they are so robust, they are so scalable. So do we really need performance testing for microservices? If yes, why? The challenges that we have currently in microservices performance, then the key aspects that we all need to look at when we start taking up a project that has microservices, the key KPIs to be looked at, and finally we'll close our session with the question and answers, which you can even ask in between if you have any. So microservices architecture. Uh, as you can see that in the diagram depicted, you have multiple services listed after an API gateway, which are talking to different databases. Now, this is a very simple microservice architecture. So basically, in our monolithic applications, we all used to have entire piece of code serving different functionalities. For example, for a retail customer, you want to search, you want to put your items in your basket and finish the order. All of these modules will be written in a single piece of code in a monolithic architecture. So if anything goes down or if anything has an issue, it will impact directly every other line of code attached to it. To move away from this, microservices came into picture where we are segregating all our modules at the minute level of granularity in terms of functionalities, putting them as separate services so that changes in one or issues in one service doesn't affect my any other operations. For example, maybe my payment gateway is not working. That shouldn't stop my users to search or to add the program items to their basket. In the meantime, I'm going to work on the payment gateway, fix it up. So my entire site will never be down. My usability aspect would be covered. So that's why microservices are so popular in today's game. They're self contained, they're very loosely coupled, they're independent interfaces, they're cloud native. Everything and anything is on cloud today. So microservices gives us a very advantage in that case. They're cloud native. They are flexible. I can just take out any piece of code at any point of time, deploy it separately. They're scalable. You can define the scalability of microservices at each and every service level. So I can scale in, I can scale out, I can plan my resources accordingly, and it can optimize my cost as well. And again, as I said earlier, they offer smaller granularity of the offered functionality. Moving on. Microservice performance testing needs. So we talked a lot about microservices, how good they are. They are scalable, they are robust. Then why do we need to performance test them? Well, basically, we know that they are scalable, but those scalability configurations are done by us. Those scalability configurations need to be validated. So we need to performance test microservices for the validation of the scalability. Service interactions. Now, since we are telling that it offers smaller level of granularity in terms of functionality, which means my services need to interact with each other. After my search is performed to add the item to the basket, I need to have some correlation with the search items so that I can put the same items in the basket. Services need to interact with each other. That interaction, is that highly performing or not? Because that has going to have an impact directly on my performance. Load balancing. We all have I guess we all are aware about load balancers. So how well my load balancers are working in, because my services will be co-deployed, they might be deployed at different regions, different AEC regions, how my balancing is working. Am I serving the correct load to all the services or not? Failover handling. So as I said that the one of the key aspects of having microservices is that failure in one of the servers shouldn't impact other. So we need to test that out, how the failure scenarios are handled in microservices. If one is impacted, the rest should work as is. Resource utilization. We have been saying that the services are very robust, scale in, scale out. That doesn't mean that I can just keep on horizontally scaling the services, put a load on my resources, or put a load on my cost, and keep serving the customer. I need to optimize my resources. I need to optimize my cost in terms of infrastructure and still serve the same network latencies, the same response time to the end user. So these are the couple of key points which we have to take care or which we actually need to consider when we start testing, performance testing a microservice. Any questions by far? All right, we'll move on. Now, potential performance bottlenecks. So, microservices have been evolving from past couple of years. There have been many case studies by the key players in the market. For example, Hotstar. Recently, during the India-New Zealand World Cup match, they hosted a huge volume of users video streaming, and their deployment is entirely on microservices cloud. So how did they handle that load? Same way, Amazon, Netflix, they all have their microservice architecture deployed in cloud and they handle vast user loads and user spikes. Based on their case studies, there are a lot of potential performance bottlenecks that have been highlighted. The most important of them all is resource contention when multiple microservices are competing for the same resources. Now, we said that microservices are deployed separately, but in most of the cases, or in majority of the cases, I should say, they are co-deployed because they are interdependent. Now, if your microservice is co-deployed, they're going to fight for the same resource within the same cluster. So if my resource optimization is not correct, it's not up to the mark, the two microservices or the n number of microservices are going to fight for the same resource, leading to a resource contention. So that is one of the potential performance bottleneck that we can anticipate. Secondly, failure at service level can trigger failure of dependent services. Again, as I said, in many cases, we are co-deploying our microservices into a same cluster. Now, if one of the service fails, what is the impact on other service? Are my other service gonna come back from that, or they will have a cascading effect or a domino effect of the failure? That needs to be validated. Ideally, the architecture that we are supporting, it shouldn't be. But again, from a performance perspective, this needs to be validated. Increase service to service interaction causing higher network latency. Now, here comes our deployment strategy also into play. We know that we have dependent services, and they might be co deployed or they might be deployed in different regions depending on the strategy that has been adopted. If our service to service interaction is having a higher network latency, it's going to impact my end user response time. So I need to work on the deployment strategy as well to avoid a network latency that will actually lead to increased response time stats. Resource exhaustion can lead to service crashes. Now, this is basically in terms of higher TPS coming in all of a sudden, and we don't have the fallback mechanism or the circuit breakers applied to the servers. That's going to have an impact on my resources, and my service pods are going to crash. Inefficient configuration of thread pool limit. Again, when you're working with microservice and when you're working in a real-time scenario, for example, for retail customers or e-commerce or even aviation, you never know when the surge of customers may come. Let's say you launch a promotional program, a promotional sales program, and all of a sudden your load went from X to 3X, which is very much possible in current world scenario. If I have not configured my thread pool contention limits accordingly, I will definitely not be able to maintain a 3x load support because my microservice would definitely scale out, but my thread pool configurations would not. So that is again one of the very important aspects that we need to look when we are planning performance testing for the microservices. Now, the approaches or the key aspects we all need to consider while designing performance strategy for any of the microservice project. The key aspects are highlighted here. shift left, service isolation test, individual service scalability, the real world load simulation, circuit breakers, and the fallback mechanism. We'll talk in details about each one of these in the coming slides now. Shift left. I guess you all must have been hearing or have heard this term by now. Everywhere we are hearing shift left, shift right in terms of testing implementations in the current agile world. What do we mean by shift left? Well, shifting left means starting our testing right from the requirement gathering phase. And when I say testing, that just doesn't mean functional testing, it also involves not functional testing. Starting at the requirement gathering itself, I need to validate if my non functional requirements are being considered while designing product. Let's say if I'm designing a product and I can anticipate my user load is going to be X, I can actually very well design it to support 20% incremental X load. So by shifting left, we are saying that we are not waiting till the code is getting delivered to us for the actual testing phase. We're going to come back very early in the game, starting the requirement gathering to ensure functional and non functional requirements are captured properly. They are considered while designing the product, and the configuration settings are right. We are not struggling with design and configuration when we are actually testing the product. So, shift left basically gives you upper hand when you actually enter the testing phase. Second is service isolation test or service virtualization. Now, as we said, that microservice is basically breaking down your code into multiple modules or multiple services, which means that definitely one service would be developed before the others. But it might have a dependency on the rest of the services or on the third parties. Then what do? Do we wait for everything to be developed? If we wait, we are going to go back to our legacy ways of working, which doesn't support shifting left. Simple way out is we do a service virtualization. We first of all we test all the services in isolation in terms of response time stats, in terms of serving to the peak loads, in terms of scalability and stress handling. And then, if the service has a dependency on the third party or any other service for the data, we go with service virtualization. There are a lot of tools available in the market these days, and service virtualization actually helps in cost reduction. Because we know that when we are actually integrating our components or the services all together, they have been tested and certified as an individual service. So when we actually start testing, we only have to solve our integration issues and we don't have to worry about individual modules. Next, and very important aspect that we all need to consider is real world load simulation. This is the basic of performance testing. And usually when we see any production performance issues, majority of the issues drills down to a one root cause that the real world load was not simulated. It was missed during performance testing. It was supposed to be X, but we were running on something else. When I say real world load simulation, it doesn't mean that you were just considering number of concurrent users or number of transactions per second. It's a distribution as well. If I have 10 functionalities in my application, all of those 10 functionalities will not be used in the same proportion by the end user. Majority of the people might be working on search. Let's say 50% of the people might be working on search. 30% might be working on just having a look at the catalogs, and 20% might be working on finishing the order. So am I simulating the right distribution of load in my performance testing scenarios? Maintaining a TPS is okay, but that TPS is segregated properly across all the scenarios or not. That is one of the very key aspect while designing your strategy for microservices. Along with that, we have to consider spikes, for example, sales or holiday season. So during sales, traffic to the site or to the application and the test spikes up in a very unrealistic manner. We have all heard case studies in the market about sites going down during sales period, very specifically during your Black Friday sales or during the Diwali sales. So have I considered those spikes, seasonal spikes in my load test simulation? They really play a very, very key role because my average production load and my peak production load would always be lesser than the spike production load during the specific holiday or sale season. So that is one of the, again, very key aspect to be considered while designing your strategy. Have you considered spikes in terms of load? Along with spikes, peak timings. Now, across the 24 hours, when my application is up and running and serving the end users, all the users would not be distributed evenly across the 24-hour test duration or a time duration. There might be a time window, 4 to 6 hours or 2 to 3 hours, depending on the site or the traffic, wherein I'm getting most of my traffic. Is that simulation being considered in my strategy or not? Because if I'm not considering that, I'm going to actually meet my average transaction per second within the specified limit of SLAs. But when a sudden surge comes, let's say, for example, flight tickets. If you're booking flight tickets, most of the people might be booking it early in the morning or late in the night when sitting with the family. Have I considered those spikes or not? So that also play a very key role in designing the performance testing or the real world load simulation. Any questions so far? All right, moving on. A very important aspect, circuit breaker and fallback mechanism. I'll just give you all a brief about circuit breakers. So in the microservice architecture, we have a phenomenon called circuit breaker. So basically what happens is if I have a couple of my services deployed onto a same microservice group, and all of a sudden I see one service not responding well, it's timing out, or it's crashed, it might have a cascading effect on other services because my load would still keep coming to that service. And since it's an error scenario and I'm going to get more load on that service, that will lead to my resource contention on the entire group, and it's going to crash the entire group. So basically what we do is we define circuit breakers. Circuit breakers can be defined at API level, it can be defined at a cluster level or a microservice group level as well. There I'm going to say that if my transaction per second for this particular service goes beyond a certain limit, I'm going to stop the service. None of the requests would be handled so that the other services in the group can perform well. So circuit breakers can be applied on transaction per second limit. It can be applied on timeouts, can be applied on your any error, other scenario or exception handling. So they play a very key role in maintaining good performance among the microservices. So while designing a strategy, we must have a very clear understanding of circuit breakers and the fallback mechanism implementation so that we can design the scenarios for the same. This is the most important aspect to be covered during designing the strategy for microservices. Now, after understanding that how the circuit breaker is implemented, how the configuration has been done for the particular circuit breaker, it's designed at what level, we need to understand the failure simulation. So let's say my circuit breaker is configured for TPS, that in case service 1 goes beyond 10 TPS, stop that service and let the other services work in parallel. We're going to fix the implementation of service 1. So we need to understand that what is my failure or fallback mechanism if my circuit breaker comes into action, to plan the load test or a performance test to test out that condition. If my circuit breaker is implemented at a transaction level, I need to put huge stress on the service to see how well the circuit breaker is handling the load scenario. After reaching beyond a certain TPS, how well my circuit breaker is getting on and off into action once the TPS has been turned back or once the configuration of the service has been changed. So change circuit breaker threshold during runtime. Now, this is one of a scenario that during a high user load, you think that I have put a circuit breaker on certain conditions, and even if that condition reaches, I think my system is going to support the load because I have the mechanism in place. So you need to change your circuit breaker threshold during runtime. But does it have a cascading effect on any of the services working in the group? So that scenario particularly needs to be tested as well. So we discussed that what are the key aspects we need to look at while designing a strategy for microservices, performance strategy. Along with that, there are certain KPIs we need to look at. So now we have individually load tested our service. We have tested that in group. We have tested the fallback mechanism and the circuit breakers. My load is entirely simulated. One key aspect that we need to look at is latency of user request service traversed over the entire network. So my services would be serving all the geographical locations, and the network latency from all the geographical locations might not be same. So while designing the strategy, we need to really keep this into account. Are we considering the network latencies across all the geographical locations and some of deployment as well? For example, so if your services are deployed in one of the AWS regions and your end user also starts from the same AWS region, the network latency would be less. But if the end user is coming over the internet, you would have a higher network latency. Have you considered those scenarios while designing your strategy so that you know what is the variance of response time and what is the variance of network latency across the network? Responsiveness of individual independent services. So, as we talked about dependent services earlier as well, if my dependent services are not co deployed in the same region, the responsiveness might be compromised because of latency occurring from the two different regions. So, in the deployment strategy, you really need to look at what are the dependent services, are they co deployed or not? And in either of the cases, what is the responsiveness, what is the response time for service to service communication? Here, we really also need to look at in the log tracing and observability aspect, which is a key monitoring aspect while load testing microservices. All each and every hop, network hop, needs to be covered in terms of logging and in terms of tracking the service request. That way, you will have a clear idea how many hops are there while traversing a request until the response is being served, and what is the response time at each and every hop, so that you can actually decide which particular hop is causing a dip in response time for the end user. Time microservices take to recover from cascading failures. Again, it drills down or it goes back to the dependent services which are co deployed into the same service group. If one of my service fails within a service group, what is the impact it's going to have on the other services? Ideally, it shouldn't have any impact, but this scenario needs to be validated. Hit rate and efficiency of caching mechanism. Now, in microservice implementation, we have multiple caching mechanisms within the service caching, external caching, DB caching. How that caching mechanism is working. If your system needs to be in sync with any other third party or any other downstream or upstream system, how your caching is working in terms of syncing. Your data, user data, should not be out of sync because of caching delays. So this is a very key aspect that needs to be load tested, how caching is working, how efficiently the caching is being handled in the microservice deployment. Service ability to handle increasing loads without performance degradation. This directly relates to your scalability testing. So you have defined your average transactions per second load for all the services, your peak loads for all the services, your spiked peak loads for all the services. But how well your service is scaling out in terms of handling the increased loads without compromising the end user response time. That scenario needs to be validated very well in microservice. And again, as we talked earlier as well, analyzing the response time and throughput, that is transaction data, from different geographical locations. So yeah, this was all I wanted to explain about the points that needs to be considered while designing a performance testing approach for microservices.